All right, so here's the problem. And so let's write our givens. Okay, so diameter is 1.6 millimeters. Specific gravity is 0.94. All right, we have a distance, delta S, we'll call it, 250 millimeters. Just SG, yeah. Yep. And I'm going to leave this number out just for a minute, okay? And we'll get back to it. So we want to find the viscosity, which I call mu. The book might call it eta, depending on the book. So it's up to you to figure out what you want. Yep. You don't have to. It's up to you. If it makes it easier for you, sure. All right, so here you can just type or write viscosity equation. And we'll put falling ball. Viscometer. And I don't know that one off my head. So mu equals gamma S minus gamma F d squared over 18 times the velocity.
What assumption do you use in this case?
One would be the ball reached terminal velocity, or the steel ball. So what does that mean for acceleration? Zero. Yep. And another one would be that the ball isn't spinning. So that creates a whole new drag force that you have to include, and we're not going to worry about that. Okay. So far, we're missing a few things, but I kind of want to say, okay, this is how maybe you would start your homework. Have the sketch, we have some of these givens, then we get to our equation and we look. All right, I actually forgot to write a couple things in our givens. So let's look at these two. Like, okay, I'm not sure what those are. I'm just going to move on, right? That's probably how you do your homework maybe sometimes. Diameter. Do we have the diameter of the ball? Nope. But let's convert it. So what do we need to do? 2. Why, does it say it's the radius? Yeah, we want to divide by... Yeah. Yep. So we bring it over how many zeros? Should be, yeah, you bring it over 3, so we have 1, 2. Is that right? That's how I do it. Count the number of zeros on 1,000, bring it over that many. Okay. Might as well convert delta S too, right? So down here we have the diameter, okay, 18 is a constant. And then we're down to velocity. That's what V is. So how do you find velocity? What's the unit on velocity?
Distance per time.
Distance per time. That's the way you could check, kind of make your own new equation, but that's not really a new equation, but something new in your mind, right? So in order to find velocity, so we'll make a heading, find velocity. V equals delta S over T. And technically it should be a delta T, so we'll put delta T. So V equals 0.25 meters over, what was it, 10.4 seconds. So what do we get? I'll get my handy dandy calculator on my phone. 0.024. Okay. All right. So we have d squared, where we have d, we have v. Now we just got to figure out what those gammas are. What is gamma? Specific weight. Yep. So find gamma of the fluid. That's the density of the fluid times G. It says that it's a heavy fluid of this oil having that specific gravity. So you multiply by 1,000, and that'll give you your density of the water. So Sg times density of water, that'll give us our gamma F. Okay, so this was 0.94 times 1,000 kilograms per meter cubed, right? Times 9.81 meters per second squared. And you get 9221.4. Sometimes you're going to have to figure out, okay, we have these weird units. How can we combine them to get a unit that you might see in the problem? Yep. So tell me what this is. Kilograms times meter over second squared. That's a newton. So try to break it up into newtons if you can. So technically, this is a newton over a meter cubed. This is probably the hardest for students to grasp, is how to combine units and how to make sure. Trust me, it's just going to take some time. Okay? If you're here and you're stuck, this is great. Then you can just email me or ask me or ask someone else, okay, what do I do? Because that's where the learning then comes in. Okay, you say, okay, how do we now combine them to get this? So now we have a newton over a meter cubed. What was that other thing in the problem? It says the steel weighs 77 kilonewtons per meter cubed. So tell me what that variable then is. That's the specific weight of the ball. Yep. So that's our new given, gamma S, 77 kilonewtons per meter cubed. And we multiply by 1,000, right? 1 kilonewton, 77, 1, 2, 3 newtons per meter cubed. All right, so mu becomes 18, what was our velocity? 0.024 meters per second. Up top was what first? Gamma of the ball, so 77,000 newton per meter cubed. Wow, that was not very good units. Minus 9221.4 newtons per meter cubed times the diameter, which was 0.0016 meters, and that whole thing was squared. And I believe when you do all this, what is it, 0.4 Pascal seconds is the unit you'll end up getting.